Classification of matter. Matter is anything that occupies space and has mass. So pretty much everything around us, your cell phone, your desk chair, your body, it's all matter. Can anybody think of something that's not matter? Light. How about ideas? Do ideas have mass? No. How about emotions? No. So there are things that are not matter, but anything that has space and mass is matter. If we use the word substance to describe a specific kind of matter, a specific instance of matter. And scientists like to classify things. So we take matter, which encompasses lots of different things, and we group it and we put it into different categories. So we can categorize it based on its state or its composition, what the components are that make it up. So we can classify these as being solids, liquids, or gases. These are the three physical states of matter. There's a fourth state called a plasma, but that's unusual and it's not something we'll be talking about in this course. So these states of matter, many things can change from one state to another. We can, especially if we think about water, it can change from solid to liquid and from a liquid to gas with increasing temperature. We can understand the differences in these three states of matter by looking at the particles. If we look here at a solid, we see that the particles, here represented as green spheres, are very close together, and they're ordered. They're making a specific geometric arrangement, and that is characteristic of solids. In a liquid, the particles are also very close together, but now the order is gone. And if we could watch this as a movie instead of just a picture, we'd see that they're kind of milling about. And then we have the gas state where the particles are much farther apart. This is not to scale. They would actually be much farther apart. But the different properties that we observe for these three states depend on what the particles are doing. So in solids, they're close together. It's important to understand that solid atoms and molecules do move, but they don't move around. They don't move past each other. So students come in three states as well. Currently, you guys are in the physical state. Okay, you're sitting in your benches, at your benches, and you're in neat, orderly rows, and you're not moving past each other, right? Are you sitting completely still? No. At the very least, I hope that you're breathing. Okay? Some of you are taking notes, some of you are fidgeting, playing with your hair, whatever. Okay? So that's what molecules and atoms do, the particles of matter. They vibrate. They move. They're wiggling around, but they're stationary relative to each other. Solids have fixed volumes and rigid shapes because of how the particles are moving. They don't move past each other, so the shape doesn't change. They're very close together, and so the volume is fixed. It's the same. So there's a couple examples of solids. We can take solids and divide them into other categories. One is crystalline. In a crystalline solid, we have long-range repeating order. So it's something like this, where there's a pattern here. Ionic compounds like table salt, diamonds, these have crystalline structures. Other solids are amorphous. A means without, and morph has to do with shape. So they are without shape. They don't have a specific shape. And examples of these are glass and plastic. In liquid matter, the molecules are still close together, but they're free to move about. And so the liquid state of students in chemistry class is during lab. My voice is almost gone. During lab, where you're moving around, we're still occupying roughly the same volume. We're still roughly the same distance from each other, but now you're moving around. You're going to the sink to wash something, you're going to the hood to get something, and everybody's milling about. And that's what a liquid does. So a liquid has a fixed volume because the particles are still very close together, and that doesn't change. But the shape is not fixed. And from our experiences with water, we understand that. You take an ice cube, which is solid, and you put it in a big bowl, and it keeps its same shape. If you take an equal amount of water and pour it into a bowl, it's going to change its shape. If you pour it into a tall, skinny container, it's going to change its shape because the particles are moving relative to each other. Because they can move, they have this ability to flow. In the gas state, the particles are much farther apart. And this happens when class is over and the students leave and you spread out all over the place and there's a big distance between you. Your volume has increased. So gas particles are free to move relative to each other like the liquids are, but there's a lot of space between them. So if you look at these are here 2 pistons, and in this one we have a solid. And if you push down on the piston, you can't squish it together anymore because those particles are already touchingly close. They can't get any closer. But with a gas, there's a lot of empty space. And so when you push down on that piston, you can squeeze the gas particles closer together and you can change its volume. So gases are compressible, liquids and solids not so much. So that's one way of classifying matter. We can also classify according to the components of the matter, its composition. And here's an overview. So the first division is between a pure substance and a mixture. In a pure substance, there's only one component. All the particles are the same. The composition is invariant. It's always the same. In a mixture, you have 2 or more different kinds of particles, and the amount of one versus the other is changeable, and that's a mixture. The pure substances can be broken into 2 categories, elements and compounds. And this is based on whether the particles can be broken down into simpler particles or simpler substances. Elements are already as simple as they can be. They cannot be broken down into simpler components, whereas compounds are made of elements and can be broken down. So an element is a substance that cannot be chemically broken down into simpler substances. The basic building blocks of matter. Lego bricks, if you will. Can you break Lego bricks with your bare hands? No, they're pretty sturdy. You can't break them by stepping on them either, although they may break your foot. They're sturdy little things. So elements are those smallest type of particles. They're the atoms. You can't break them down into anything simpler. But a compound has 2 or more elements in a fixed proportion. So like water, there's always 2 hydrogens for every 1 oxygen. The proportion is always the same. That's what makes it a compound as opposed to a mixture, because you can mix hydrogen and oxygen together as a mixture, but it's not a compound because you could have more or less hydrogen. Most of the elements are chemically reactive and they combine with other elements to form compounds. You don't find individual elements very much in nature. They're usually combined into compounds. We can also divide the mixtures into two different groups, heterogeneous and homogeneous. We use a lot of prefixes in science. So hetero and homo are prefixes. Hetero means different, homo means the same. So a heterogeneous mixture, you can see that there's two different things there. A homogeneous mixture is going to be the same composition throughout. So the categorization depends on how uniformly the substances in that mixture are combined. I think we've got some examples here. So heterogeneous, the composition varies. So if you have salt and sand and you mix them together, if you look real closely at that, you can see the individual salt crystals and the individual sand grains, right? The composition of each of those little particles is different, and you can see that. Another example might be macaroni and cheese. There's the cheese sauce, and then there's noodles in it. There's lumps, right? Or you think of oil and vinegar salad dressing, Italian salad dressing. You shake it up, but the oil always comes to the top, and the water part settles to the bottom, and then you've got the flakes of the herbs and stuff. And you can see there's differences. It's heterogeneous. Homogeneous is going to be the same throughout. It's going to be uniform. So sweetened tea, in the South they just call it sweet tea. Lived in North Carolina for 3 years. So sweet tea, you dissolve sugar in your tea and it mixes uniformly. Once you've mixed it up, the top part of the tea tastes just as sweet as the bottom, or the middle on the left, or the middle on the right. It's the same everywhere. And that's homogeneous. Homogeneous means same. It's uniform. Something like Kool-Aid. Kool-Aid would be homogeneous. There's red dye number 40 in there, and there's sugar, and there's other stuff in there, and there's water. But it's the same throughout, right? So that's homogeneous. So we need to be able to identify things as homogeneous or heterogeneous. And this gets a little tricky sometimes. On exams, I'm going to try to use things that should be common knowledge. So I'm not going to try to trick you. But let's look at these one at a time here. So gasoline. Gasoline is a mixture. It's got octane in it, and it's got a bunch of other compounds in it as well. It's not a pure compound. It's a mixture of different compounds. Is it heterogeneous or homogeneous? It's homogeneous. Now, if you've never actually seen gasoline, because maybe your dad didn't make you mow the lawn, you may not have seen gasoline, but gasoline looks a lot like water. It doesn't have much of a color. It looks like a clear liquid, and it's all the same. How about a stream with gravel on the bottom? Heterogeneous, because there's different parts. How about air? We're going to say homogeneous, although living in the Central Valley, is the air always homogeneous? No. Sometimes when I drive into Fresno, I see this yellow haze. It's like, ew. Right? But in general, air is considered to be homogeneous. It mixes. How about brass? What's brass? Well, think of a brass doorknob. Brass is actually a mixture of different metals. It's not an element. Is it homogeneous or heterogeneous? It's homogeneous. Now the question here is asking us, identify as a homogeneous mixture or a heterogeneous mixture. How about copper metal? This one's a trick. It's an element, it's not a mixture. Ooh. Copper is an element. Because it's an element, it must be homogeneous. So if we had to choose homogeneous or heterogeneous, like maybe on Mastering Chemistry and it was making you pick, you would choose homogeneous, but it's not a mixture. Mixtures can be separated. The components of a mixture, because they are different, are going to have different physical or chemical properties. And there are many different techniques used to separate mixtures. One method is called decanting, which means to carefully pour the top layer off. So if you have a mixture of sand and water, and you wait for all the sand and stuff to settle to the bottom, you can separate them pretty well by pouring very carefully the water off of the top. We can do that because the sand is a solid and the water is a liquid. We can separate a homogeneous mixture of liquids by a process called distillation. And here's an illustration of an apparatus for this. You take your mixture here. We can do this with liquids that have different boiling points. One is more volatile, it boils at a lower temperature than the other. So if you have a mixture here, say of water and alcohol, and you heat this, the alcohol will boil first and will go into the gas state and try to escape. But the only way it can get out is through this tube. This is a condenser, and it's got cold water running around the outside, which cools the alcohol down into a liquid, and then it comes and it drips out into this flask over here. And as you heat this, the alcohol escapes and the water stays behind. And so we can separate things based on difference in boiling point. Filtration is one that you actually use at home. If you've ever made spaghetti, you've separated things using filtration. Most coffee makers use some method of filtration. So if you have an insoluble solid, the coffee grounds or the spaghetti, and a liquid, the water, you can separate them by filtration. So the filter can be paper, which allows the water to go through but not the coffee grounds, or it could be something with larger openings like a colander that traps the solid spaghetti but lets the water run through. And again, there you're separating based on a difference in a physical property, the physical state.